Hey, welcome to The Explainer. Today, we're diving into the secret world of these amazing new computer programs. We're calling them word wizards, but you might know them by their more technical name, large language models.
So just imagine for a second. What if you had a buddy who's basically read the entire internet? A friend who could write a song for you, help you with your homework, and even tell you a funny joke. Sounds like something out of a movie, right? Well, it's not. This is what these word wizards are starting to do, and we're going to pull back the curtain and see how the magic trick actually works.
So here's what we've got lined up. First, we'll get a handle on what these language models really are. Then we'll check out their family tree to see how they got so smart. We are going to find out their secret recipe, see some of their most surprising magic tricks, learn how we teach them to be polite, and finally, we'll ask, what comes next? Okay, let's get right into it. What exactly is a word wizard? What's the big idea here?
Well, at its core, a large language model, or LLM for short, is really just a computer program that's gotten incredibly good at one thing, playing a super advanced game of guess the next word. Seriously, that's it. It has read a gigantic library of text, and by practicing that game billions and billions of times, it starts to see patterns. It gets so good at predicting what word comes next that it can write whole stories or poems that feel like a person wrote them. It all comes down to that one simple, powerful trick.
You know, to really understand the difference, think about the spell check on your phone. It's useful, sure, but it's pretty simple. It just looks at one word at a time. An LLM, though, it's on a whole other level. It's more like a super smart idea generator. It doesn't just see one word. It understands the whole conversation, the context, the vibe. It finds these deep, complex patterns in language. And that's what makes it a creative partner, not just a simple tool.
Now, these powerful models didn't just show up one day. No way. They've actually got a pretty interesting family history, and they got smarter and smarter with each generation. So let's take a look at their family tree and see how we went from simple calculators to actual creators. So in the beginning, back in the early 2000s, you had the word counters. They were pretty basic, just counting how often words appeared next to each other. Then, around 2013, we got the feature finders. These were smarter, and they could find patterns on their own, which was a big help. After that, around 2018, the task solvers came along. You could train them to do specific jobs, kind of like an intern. But then, around 2020, everything changed. We got the word wizards, like GPT-3. These models are so big and so well trained, they can figure out how to do almost any language task you give them, right out of the box.
So you gotta be asking, how did they get that smart that fast? What's the secret recipe here? Well, it really boils down to two key ingredients. First, you have to scale up. That's just a fancy way of saying you make its brain absolutely gigantic, and you feed it a library of information that is unbelievably huge. The second ingredient is training. This is where it just practices and practices and practices that guess the next word game, billions of times, tuning its brain with every single guess. And take a look at what's in that library. For a model like GPT-3, most of it, a whopping 60%, comes from just a giant snapshot of the internet. But it also reads tons of books, online conversations, and all of Wikipedia. This crazy diverse diet is what gives it such a well-rounded view of the world, from science to history to, cat memes. And when we say its brain is big, we mean it's just massive. GPT-3 has 175 billion parameters. The best way to think about them is like tiny little knobs or switches inside its brain. Every time it learns a new pattern, it adjusts these 175 billion knobs just a little bit. It's that sheer number that lets it remember and understand so much complexity. But hey, you can't just feed it the whole messy internet. You gotta clean the library first. So step one is quality filtering. They get rid of all the messy, junky, or harmful stuff. Step two is deduplication. You gotta tear out all the duplicate pages so it doesn't just learn to be super repetitive. And finally, you have tokenization, which is just breaking down all the words into smaller, bite-sized pieces that the model can easily work with. Okay, now this is where the story gets really wild. This is the level up moment, because when you make these models big enough and you train them on enough stuff, something completely unexpected happens. They don't just get better at guessing words, they start doing new things, real magic tricks that nobody ever programmed them to do. Yeah, scientists have a name for this: emergent abilities. These are skills that just appear out of nowhere once the model gets big enough. They don't exist in the smaller models at all. It's like if you taught a kid just words and sentences, and then one day they suddenly understood a really complex joke. It's this mysterious leap in understanding that we're all still trying to figure out.
So what kind of magic tricks are we talking about? Well, there's in-context learning. You can just show the model a few examples of something and bam, it instantly knows how to do it without any extra training. Then there's instruction following, where it can understand and follow brand new commands it's never, ever seen before. And maybe the most amazing one is chain of thought reasoning, where it actually learns to think through a complex problem step by step, just like we do.
And you're not going to believe this, but sometimes all it takes to unlock that amazing skill are magic words. It turns out if you just add the simple phrase, "Let's think step by step" to your request, the model is way more likely to show its work and get the right answer on hard problems. It's like a secret cheat code for better thinking. All right, so you've got this all-powerful word wizard. But what happens if it's kind of a jerk? Or if it makes stuff up? I mean, with great power comes great responsibility, right? Well, that's when the wizards have to go to finishing school. And that process is called alignment. The whole idea behind alignment is that being smart isn't enough. We need to make sure these models are also helpful, honest, and harmless. It's all about steering their incredible intelligence so it actually aligns with what we as humans find useful and good. So how do you teach a computer good manners? Well, one popular way is to keep people in the loop. First, human teachers write up a bunch of really good, helpful answers. Then, the model tries to write its own answers, and the humans rate them from best to worst. From those ratings, a special reward model is created that learns what humans like. Finally, the main LLM is trained to act in a way that gets a high score from that reward model. It's basically like giving it a treat for good behavior. So, from just guessing the next word to reasoning through problems and even learning some manners, these word wizards have come an incredibly long way in a very short time. But you know what? Their story is really just beginning.
We've done it. We've basically taught machines to talk. We've given them one of our most powerful tools, language. So the next chapter isn't just about what they can do, it's about what we ask them to do. What are the big challenges, the creative ideas, the helpful tasks we should tackle together? The adventure is just getting started. Thanks for watching The Explainer.